Hello everyone and welcome back to Geotech Masters. Earlier, we looked at the weathering of the small rock piece in our hand. We called that material weathering. But today, we need to look at the bigger picture. We are going to discuss rock mass weathering. Why do we need a separate classification? Because a rock mass is not uniform. You might have strong, fresh boulders floating in a matrix of weak, decomposed clay. In this episode, we'll learn how to classify the entire ground profile using a standardized 6-grade system. We'll move from grade 0, which is fresh rock, all the way to grade 5, which is residual soil. This system helps us understand how the ground changes from the surface down to the solid bedrock. Let's explore these together.
Before we open the standard, let's think about some common site challenges. Have you ever been drilling and hit something hard, thought it was bedrock, but then punched through into soft soil again a meter later? This is the core stone problem. It is one of the most dangerous traps in geotechnical investigation. We need to know how to identify and classify these floating blocks. Also, how do we describe a layer that is 50% rock and 50% soil? Is it a rock layer or is it a soil layer? The ISO standard gives us a specific framework to answer these questions using zonal weathering. Let's clarify the difference between material and mass weathering. Earlier, we learned terms like discolored and decomposed for the material. That describes the substance itself. Mass weathering describes the distribution and proportions of that material across a large area. It looks at the discontinuities. Are the joints stained? Is the rock solid, or is it broken into blocks surrounded by soil? The standard states that we must describe the relative proportions of fresh and weathered rock. We treat the ground as a system. This is critical for slope stability, as failures often happen through the weaker, weathered zones within the mass. The standard suggests we view the